Hello wonderful person, this is Anton, and today we're going to be discussing the incredible year for science when it comes to research on black holes that happened in 2021. In other words, we're going to be reviewing some of the major findings from 2021 in regards to various types of black holes and various properties of black holes that have been found last year. And honestly, it was an extremely productive year for black holes. It might have not really been a very happy year for many other reasons, but when it comes to black hole research, it was pretty incredible. And so let's discuss some of these major findings and what they mean, but I guess more importantly, if you'd like to learn more about each individual study, as always you can find it in the description below or by watching one of the older videos that describe it in more detail. So what exactly did we find? Well, some of the first major discoveries were coming from the research behind nanograv, the North American Nanohertz Observatory for Gravitational Waves. And as the name implies, this is a gravitational wave observatory, but instead of studying the collision between black holes, it actually analyzes the properties of various neutron stars, various pulsars, located all across our galaxy, and then by studying the gravitational waves between these pulsars, and by essentially constructing a kind of a three-dimensional map, the scientists try to figure out what's actually causing all of this, and what are potential implications from all of these discoveries. Well, some of the discoveries suggested that there were actually gravitational waves from what's known as the stupendously large black holes, so something that's even larger than supermassive black hole, with many of these black holes having mass in billions and billions masses of the Sun. But no specific black hole was identified, just the idea behind these black holes very likely existing. The paper is of course in the description below. Then there was also a discovery of an unusual black hole that seemed to have some sort of pattern going on. It was actually decreasing its outbursts every 114 days. And although it's not entirely clear why it was doing so, it's very likely because of some sort of a star collision that might have actually disrupted something around the black hole. Although at this point it's still not entirely certain. It's just very unusual to have a black hole with such a predictable pattern, and a pattern that seems to have no good explanation just yet. Then there was a discovery of this. The scientists here were actually looking for an intermediate mass black hole inside a typical globular cluster. Instead, what they discovered was a huge number of really small black holes, all found in the center of the cluster. And this was somewhat unexpected. So basically it was a cluster filled with a tremendous number of small black holes. A cluster known as NGC 6397, located around 7,000 light years away from us. Then there was another surprising discovery from another cluster, the cluster known as Palomar 5, that seemed to contain a huge number of black holes on the inside, with the black holes representing a major part of the mass of the entire cluster, and this was kind of difficult to explain as well. With the only good explanation so far suggesting that the cluster was just disrupted by our galaxy, leaving behind a lot of black holes on the inside and basically removing a lot of stars and a lot of gas, which also means that it was probably some sort of a dwarf galaxy in the past. And then we have this map, and this is of course the iconic map created by the Australian scientists sometime last year that represents a map of black holes around the night skies. A map that's only visible in the radio light, with each of the dots representing a supermassive black hole emitting a lot of radio light. And so the stars here are obviously not the stars, they're black holes. Then there were some other experiments involving analog black holes, and that's basically when you try to create something that resembles a black hole, for example using acoustic or sound waves. And in this case, the scientists were able to once again produce Hawking radiation in this type of analog black hole. In other words, once again sort of proving that Hawking radiation or radiation coming from black holes could be real after all. We also had some major updates from the iconic M87 black hole, with scientists now being able to identify and even see the magnetic lines produced by extremely powerful magnetic field around the black hole, including different twists and turns produced in the jet itself. While at the same time, the same team behind the Event Horizon telescope then also saw a lot of other observations from the nearby Centaurus A galaxy, with the similar twisted jet detected there as well. And then there were quite a lot of discoveries when it came to intermediate mass black holes. The black holes whose existence was not certain up until a few years ago. And last year was basically the sort of definitive proof that they do exist. Several major intermediate black holes were found in various galaxies, including one that was about 91,000 masses of the Sun in the nearby Andromeda galaxy. with the other ones discovered through gravitational wave analysis, but also by looking at gravitational lensing from distant objects, with many of them differing in mass as well, between about a few hundred masses of the Sun up to about several thousand masses of the Sun. And then we had the discovery of what seems to be the closest black hole to the solar system, at a distance of just about 1500 light-years away from us. Currently it doesn't really have a good name, but the scientists are referring to it as the unicorn, mostly because of its uniqueness. Now naturally it's probably not the closest black hole to us, but it's the closest that we've currently confirmed to exist. Black holes obviously are difficult to find, especially if there's nothing in their orbit. So chances are the scientists will find something even closer once new techniques are developed and once better telescopes are available to us. Then, for the first time ever, we got to see the light coming from behind the black hole, as obviously predicted by various theories. But this was the first official time it was proven to come from behind the black hole and not from any other region. This was actually a pretty interesting study, and it sort of showed us what's referred to as the light echoes. We've also had quite a lot of various studies involving our own central black hole, Sagittarius A star. First of all, studies confirming that it seems to be there and it seems to be a black hole. That's about 4.1 to maybe 4.3 million masses of the Sun. But also some other studies explaining some of the mysterious objects, such as the objects we sometimes refer to as the G objects, with some of the explanations suggesting that the central black hole region seems to actually have some kind of a star formation going on, where then these stars are disrupted and turned into these unusual stretched objects that have been detected by the scientists in the last few years. But because more studies are still ongoing right now, we're going to be discovering even more about Sagittarius A star, most likely this year or possibly in the next few years as well. So I'm actually super excited to talk about these new discoveries once they come out and once they become official. By the way, one of the most recent discoveries coming from the central region was the discovery of what seems to be a leftover jet from an eruption very likely a few thousand years ago, or possibly even longer than that. And this is of course an official proof that our black hole was active not so long ago, and chances are it's going to become active in the distant future as well. But more importantly, it gave us a reason to figure out if these types of activities have any effect on, for example, planet Earth. And if there are any effects, it would be a really huge discovery. But once again, more about this later. So obviously make sure to subscribe. Then a few months ago, completely by accident, the scientists discovered a completely new property of black holes. Currently they refer to it as quantum pressure. And so even though before the scientists always thought that black holes have only three properties, mass, charge, and spin, now it seems that there is a fourth one as well, although that one is not particularly powerful. Nevertheless, this particular paper in some sense is groundbreaking because finding something like this is a big deal. Basically, the black holes now have four properties. And speaking of properties, this other paper also sort of argued that, well, because of the expansion of the universe, a lot of ancient black holes might actually be gaining mass, and that's the general property of the universe itself. In other words, as the universe expands over time, a lot of black holes might be gaining mass, and quite a lot of it. And some of the most ancient black holes might have gained a lot of mass in the process. But because this is a theoretical study with no actual observations, we don't really know how to prove any of this just yet. The study in the description. Then, a few months ago, LIGO reported 35 new gravitational wave detections, with some of them somewhat difficult to explain. A lot of them were either really small or had mass difference that just was kind of difficult to comprehend. And also these detections involved certain intermediate mass black holes as well. This was actually once again a somewhat unexpected and somewhat important discovery. And then by looking at the changes in the redshift and blueshift of various stars, the scientists have also found some unexpected black holes not so far away from us. For example, one of the more surprising discoveries was a relatively massive black hole over 3 million masses of the Sun, located in a nearby dwarf galaxy known as Leo 1. And this is actually something nobody really expected. How could a dwarf galaxy that seems to possess way less stars and less mass than the Milky Way galaxy contain a black hole that was so ridiculously massive? This particular question has no answer right now, but it was a really cool discovery. Then, using a relatively similar technique, the scientists have officially confirmed the nearest supermassive black hole pair to us, located in the galaxy you see right here. This galaxy is known as NGC 7727, and these two dots, these basically represent relatively large regions with black holes in the center of them, with the black holes then orbiting around one another. And based on the unusual morphology in this galaxy, all of this suggests that this is a result of a collision between two different galaxies. Then we had the official proof of something known as the Penrose process. And this is the idea where scientists believe that you can technically steal some of the energy from a black hole if a particle, or in this case a gamma ray, passes inside what's known as the ergosphere of a spinning black hole and then leaves this region with more energy than it entered. This extra energy comes from the black hole itself. And it was officially proven that this indeed happens around black holes, with the detection of this gamma ray burst and the thorough analysis suggesting that it indeed seemed to have gained energy after the black hole was created. But extracting energy from an actual black hole is obviously still way beyond our capabilities. Anyway, then, not so long ago, we've talked about this, the beautiful image created by one of the radio astronomers in Australia of the nearby Centaurus A. And this thumbnail right here sort of explains to you what's happening here. This is an extremely large object in the night skies. If we could see radio waves, it would be about 16 times larger than the Moon. And all of this naturally produced by the massive black hole in the center of Centaurus A. And lastly, one of the other major discoveries was the confirmation that something known as the black hole tsunamis might exist as well. It's sort of shown in this illustration right here, with the tsunami itself being this really large wave of gas, very likely anywhere from 10 to maybe even 50 light years across, produced by the central black hole and the interaction with the accretion gas around the black hole itself, which then results in the production of these really large gas waves. And these tsunami waves then probably have a lot of effects on the nearby star formation and possibly even formation of stars farther away from the black hole itself. Although naturally what effects it has on the galaxy is not really known right now. So a really exciting year for black hole discoveries, and hopefully 2022 ends up being just as productive as well, providing us with some additional answers about these mysterious objects. As always, find all of the links and of course the videos mentioning a lot of these studies in the description below. On that note, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.